Hi friends, how are you? This is Mohsen Khan on Meezaan TV with a new video lecture on random access schemes. In this lecture, we will know about what are random access schemes, how they impact in wireless communication, and why we need random access schemes. Before starting the lecture, it is requested to please subscribe the channel and press the bell icon so that all the videos reach to you first. Random access are contention based method. No station is superior to another station and none is assigned the control over another. In this technique, no station permits or does not permit another station to send data. That means at each instant, a station that has data to send uses a procedure defined by the protocol. No station permits or does not permits another station to send data. This means that there is no impact of a station on another station to allow them to send data. At each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send data. This decision depends on the state of the medium, if the medium is idle or busy. Now in this slide we will discuss about why we called it random access and contention based technique. Why we called it random access scheme. So in random access scheme there is no scheduled time for a station to transmit the data. In other words, transmission is random among the station. Therefore, these methods are also called random access schemes. Why we called it contention? Because there is no rule to specify which station should send next. Station compete with each other to access the medium. That's why these methods are also called contention based methods. As we discussed in the previous slide that each station has the right to the medium without being controlled by any other station. It will cause the conflict or collision if more than one station tries to send the data. In this situation, the frames will be destroyed or modified. So to avoid these conflicts, each station follow a procedure to answer the following questions before sending the data. When can the station access the medium? What can the station do if the medium is busy? How can the station determine the success or failure of the transmission? What can the station do if there is an access conflict? Now, based on the questions arises in the previous slide, there are two main types of random access techniques has been defined. The one is ALOHA technique and the second is carrier sense multiple access technique. Remember that carrier sense multiple access scheme is divided in further two types named collision detection and collision avoidance. The simplest ALOHA technique, also called the pure ALOHA, was developed at the University of Hawaii in early 1970s. This protocol is designed for wireless communication, but it can be used on any shared medium. In this algorithm, any terminal is allowed to transmit without considering whether channel is idle or busy. If packet is received correctly, the base station transmit in acknowledgement. If the base station does not receive an acknowledgement, it retransmit the packet after waiting a random amount of time. In this algorithm, the collision between frames may occur if there are two or more than two stations attempt to send data simultaneously. This diagram shows the chances of collision in pure ALOHA scheme. This is clear that first frame of station 3 has been transmitted without collision. At the first collision duration, the first frame of station 2 and the first frame of station 4 has been collided. Then each station wait for a random time. After that random time, each station transmitted their frames. At collision duration 2, almost all of the frames of each station has been collided. Now in this diagram, the whole process of pure ALOHA has been derived. Each station starts with a zero backup. Each station sends its data frame and wait for an acknowledgement. If the packet has been received successfully at the receiver, it will send an acknowledgement. Otherwise, the station will increment its backup and wait for a random time. If the random time of backup has been expired, then it will retransmit the packet again. The vulnerable time is the time in which there is a possibility of collision. In this case, we assume the stations send fixed length frames, with each frame taking TFR second to send. Figure shows the vulnerable time for a station A. Now, station A sends a frame at time T. Now imagine station B has already sent a frame between time T minus TFR. This leads to a collision between the frames from station A and station B. The ends of B's frame collide with the beginning of A's frame. On the other hand, suppose that station C sends a frame between T and T plus TFR. Here there is a collision between frames from station A and station C. The beginning of C's frame collide with the end of A's frame. Now looking at the figure, we see that the vulnerable time during which a collision may occur in pair ALOHA is 2 times the frame transmission time. Slotted ALOHA was invented to improve the efficiency of pair ALOHA. In slotted ALOHA, we divided the time into slot of TFR second and forced the station to send only at the beginning of the time slot. If a station misses the beginning of a time slot, it must wait until the beginning of the next time slot. This means that the station which started at the beginning of this slot has already finished sending its frame. Therefore, the chances of collision has been reduced as compared to pair ALOHA. But there is still the possibility of collision. If we see the diagram, if 2 stations try to send at the beginning of the same time slot, there will be a collision. But remember that the collision duration is reduced to TFR seconds, which is half of the pair ALOHA. This diagram shows the vulnerable time or the collision time for slotted ALOHA. This is clearly shown from the figure that the vulnerable time is TFR now in this technique.
Now cheating, everything she do so pleasing. My babe, true little baby, my babe, she don't stand no fooling, my babe.
To minimize the chance of collision and improve the performance of share medium, the carrier sense multiplex scheme has been introduced. In this technique, each station must listen the medium before transmission. It is based on the principle of listen before talk. The chances of collision may be reduced if the station first senses the state of the medium, and if the medium is free, the station will transmit. Otherwise, the station will wait for a random amount of time. Remember that with CSMA, the chances of collision is reduced as compared to slotted ALOHA, but not completely eliminated. The vulnerable time for CSMA is the propagation time TP. This is the time needed for a frame to propagate from one end of the medium to the other. When a station sends a frame and any other station tries to send a frame during this time, a collision will occur. But if the first bit of the frame reaches the end of the medium, every station will already have heard the bit and will refrain from sending. Figure shows the worst case. The leftmost station A send a frame at time T1, which reaches the rightmost station D at time T1 plus TP. The gray area shows the vulnerable area in time and space. What should a station do if the channel is busy? And what should a station do if the channel is idle? These are 2 different cases, but in these cases, persistent method is used. There are 3 methods have been devised to answer these questions: the I persistent method, the non-persistent method, and the P persistent method. The I persistent method is the simplest and straightforward method. In this method, the stations continuously sense the medium. After the station finds the medium idle, it sends its frame immediately with probability I. This method has the highest chance of collision, as if there are 2 or more stations may find the line idle and send their frames immediately. This slide shows the diagram of I persist method. In the first diagram, we see that the station continuously senses the medium which is busy. When the medium is idle, the station immediately sends their data. In the non-persistent method, a station that has a frame to send first sends the line. If the line is idle, it sends immediately. If the line is not idle, it waits a random amount of time and then senses the line again. This approach reduces the chances of collision because it is unlikely that 2 or more station will wait the same amount of time and retry to send simultaneously. Furthermore, this method also reduces the efficiency of the network, as the station remain idle when there may be stations with frame to send, but their random time is not allow them to send the frame. This slide shows the diagram of the non-persistent method. Both of the diagrams shows that a station sends the medium. If the medium is busy, it waits for a random time. When the station is idle, it immediately transmits the data. Persistent method is used if the channel has time slot with a slot duration equal to or greater than the maximum propagation time. This approach combines the advantages of the other two strategies, the chances of collision and improve efficiency. In this method, when the station finds the line idle, it follows these steps. First up, the station sends its frame with probability P. In the second, station waits for the beginning of the next time slot and check the line again with probability Q equal to 1 minus P. Now, if the line is idle, it goes to step 1. If the line is busy, it acts as though a collision has occurred and uses the backup procedure. This slide shows the P-persistent method in more detail. If we see the diagram, each station continuously senses the medium. When the medium is free, the station sets a probability P. If the probability is greater than P, then the station waits a time slot duration and then check the medium status. If the medium is idle, it again sets the probability P. Otherwise, it goes to use the backup process.
Now cheating, everything she do, so pleasing. My babe, true little baby, my babe, she don't stand no fooling, my babe.
The carrier sends multiple access schemes with collision detection augment the algorithm to handle the collision. In this method, a station monitors the medium after it sends a frame to see if the transmission was successful. For a successful transmission, the station is finished. For a non-successful transmission, the frame is retransmitted. But in case of non-successful transmission due to collision, a collision signal is sent to each transmitting station. When the transmitting system receives the collision signal, it will abort the transmission immediately. This slide shows the better understanding of CSMA-CD algorithm. Let us look at the first bit transmitted by the two stations involved in the collision. Although each station continues to send bits in the frame until it detects the collision, the diagram shows what happened as the first bit collide. You can see in the diagram that a collision signal is sent to the transmitting stations. When the transmitting station receives the collision signal, it aborts the transmission for a random time. For CSMA-CD to work, we require a restriction on the minimum frame size. May have a long frame has a long transmission time, while the transmission time of a small frame is small. Now consider the worst condition. If the collision is occurred with the last bit of the frame and near the receiving terminal, it means the frame take the whole transmission time. Now the collision signal will take the transmission time to reach the transmitting station of that frame. Since the vulnerable time T4 should be double of the transmission time. The process is shown in the next slide. As we discussed in the previous slide, when the collision is occur between the S and C frame, the S frame take almost the whole transmission time, while its collision signal will also take almost the whole transmission time. In this case, the vulnerable time will be almost the double of the transmission time. If we see the figure in this diagram, this is almost similar to the one of the ALOHA protocol, but there are differences. The first difference is the addition of the persistent process. We need to sense the channel before we start sending the frame by using one of the persistent processes we have discussed previously. The corresponding box can be replaced by one of the process shown in figure. The second difference is the frame transmission. In ALOHA, we first transmit the entire frame and then wait for an acknowledgement. In CSMA-CD, transmission and collision detection is a continuous process. We do not need the entire frame and then look for a collision. The station transmit and receive continuously and simultaneously using two different ports. We use a loop to show that transmission is continuous process. We constantly monitor monitor in order to detect one of the two conditions. Either transmission is finished or a collision is detected. Either even stop transmission when we come out of the loop. If a collision has not been detected, it means that transmission is complete. The entire frame is transmitted. Otherwise, a collision has occurred. The third difference is the sending of a short jamming signal that enforces the collision in case other stations have not yet sensed the collision. In CSMA-CD, there are three levels of energy in a channel: the zero, normal, and abnormal. At the zero level, the channel is idle. At the normal level, the station has successfully captured the channel and is sending its frame. At the abnormal level, there is a collision and the level of the energy is twice the normal level. The energy levels are used when a station that has a frame to send or is sending a frame needs to monitor the energy level to determine if the channel is idle, busy, or in collision mode. The throughput of CSMA-CD is greater than that of the pair or slotted ALOHA schemes. The maximum throughput is based on the persistent method and the value of P is the persistent approach. For I persistent method, the maximum throughput is around 50%. For non-persistent method, the maximum throughput can go up to 90%. Now we are moving to the carrier. The carrier sends multiple access with collision avoidance schemes. In CSMA-CA, we need to avoid collision on wireless network because they cannot be detected. CSMA-CA avoids collision by using three strategies: the interframe space, the contention window, and the acknowledgement. The figure shows the interframe space and the contention window concept. In IFES method, the collision are avoided by different transmission even if the channel is spawned idle. When an idle channel is spawned, the station does not send immediately. It waits for a period of time called the interframe space or IPS. This is because it is probable that a distinct station may have already started transmitting and the signal of that station has not yet reached to this station. If after the IPS time the channel is still idle, the station can send, but it still needs to wait a time equal to the contention time. The contention window is an amount of time divided into slots. As we see previously in the diagram, a station that is ready to send chooses a random number of slots. The number of slots is the window changes according to the binary exponential backup strategy. In this strategy, this means that it is set to one slot the first time and then doubles each time the station cannot detect an idle channel after the IPS time. This is very similar to the P persistent method, except that a random outcome defines the number of slots taken by the waiting station. The station needs to sense the channel after each time slot. In CSMA-CA, with all these precautions, there is still may be a collision. In addition, the data may be corrupted during the transmission. The positive acknowledgement and the timeout timers can help guarantees that the receiver has received the frame accurately. This figure shows the procedure of CSMA-CA. Note that the channel needs to be sensed before and after the IFS. The channel also needs to be sensed during the contention time. For each time slot of the contention window, the channel is sensed. If it is spawned idle, the timer continues. If the channel is spawned busy, the timer is stopped and continues after the timer becomes idle again. CSMA-CA was mostly intended for use in wireless networks. Procedure described above, however, is not sophisticated enough to handle some particular issues related to wireless networks, such as the hidden node problem and exposed node problems. We will see how these issues are solved by augmenting the above protocol with handshaking feature in the next lecture named Wireless LAN. I think this is enough for today. In the next lecture, we will discuss about the wireless LAN IEEE 802.11, their working, and the problem of hidden and exposed node problem arises in wireless LAN.
If you like this video on Meezaan TV, please subscribe us and also press the bell icon for more videos.